In 2021, the James Webb Space Telescope, or JUICE, was launched from Kourou, France, to study at Lagrangian point L2. The cosmic bodies and distant galaxies around us, which can help us learn more about the birth of the universe. Equipped with large mirrors and revolutionary instruments, James Webb was able to make several important discoveries for the scientific world. In just 1 year of the mission, including such complex cosmic processes as star formation and their death. Today, you'll learn about JUICE's most remarkable discoveries to date. From the first detailed image of a cluster of galaxies to a new exoplanet. Galaxy Cluster SMACS 0723. One of Webb's first images was of the Galaxy Cluster SMACS 0723, located 4 billion light-years from Earth. This was not a discovery. The cluster was first explored by Hubble. However, thanks to its cameras, Webb was able to provide a very detailed image, revealing to scientists hundreds of previously unseen small galaxies. Interestingly, Webb made this image in just 12 hours, when it would have taken Hubble several weeks. Webb's photos will allow scientists to study young galaxies before they merge into larger spiral galaxies. For example, a study led by Rowan Naidu of Harvard University indicates that some galaxies there may have formed in as little as 300 million years after the Big Bang. In addition, scientists noticed elongated galaxies that also appeared simultaneously in different places. According to the research of astronomer Massimo Pascal, the cause of stretching may be the gravity of the galaxy cluster, which distorted the light, causing galaxies to appear in different places. The scientist also noted the elongation of SMACS 0723. It could be caused by its collision with, presumably, another galaxy cluster. The Cartwheel Galaxy, the next important image of Webb, was a rare ring galaxy, the Cartwheel, 500 million light-years away. It was discovered back in 1941, but a detailed image was only obtained now. Its strange appearance, reminding us of a wooden carriage wheel, with a circle in the center and diverging spokes, probably formed as a consequence of a high-speed collision between two galaxies over 400 million years ago. Therefore, it's likely that the Cartwheel Galaxy looked just like our Milky Way before the collision. Moreover, Webb discovered that the core of the wheel contains a large amount of hot dust, and that the brightest regions emanating from the center contain many young stars. That is, as the galaxy expands, it pushes dust and gas outward, forming stars. The Cartwheel Galaxy is still transforming after the collision, so further observations by Webb could reveal more of the mysteries of this galaxy and also look at the star-forming process. South Ring Nebula. In July of 2022, Webb captured the last moments of a dying star that had been emitting gas and dust for several millennia, forming the South Ring Nebula. This nebula, only 2,000 light-years away, was also explored by Hubble, but it only captured one star there, very bright in the infrared. As the emission continued, the star, which was 3 times the size of the Sun, shrank significantly, turning into a white dwarf. Because of this, the star could not shine brightly. Scientists then concluded that all the material ejected by the star must have formed a dust disk, and that would have glowed when heated. Such a dust disk could only be created by another star. Moreover, Webb noticed another oddity. The nebula has lines along its edges. It's unlikely that the dwarf itself could have created such patterns. Thus, Macquarie University astrophysics professor Orsola Di Marco believes that the white dwarf may have several companion stars that scattered all the material and created a disk around the central star. Finally, Webb confirmed that there is a second young star near the dwarf, although no other stars are visible. Scientists speculate that they are either too dim or have already been absorbed by the central star. Therefore, Webb's study will help scientists not only learn more about this association of stars, but also to study the chemical composition of the ejected material. L1527. In addition to the death of the star, Webb was able to capture its birth. Webb succeeded in capturing the bright clouds emitted by the newly formed star, L1527, at a distance of about 460 light-years. The star emits layers of dust and gas in different directions, so the appearance of this nebula resembles an hourglass. The color of the clouds is determined by the thickness of the dust, an orange color where the dust is denser, and vice versa. The thinner the layer, the bluer the color would be. Scientists estimate that this star is only about 100,000 years old. When a star is formed, about 10 million years or more. Also, NASA researchers believe that L1527 is already approaching the generation of its energy through nuclear fission, so it will soon be able to ignite on a cosmic scale. Moreover, the barely visible line that crosses the clouds is a protoplanetary disk, and it is the size of our solar system. Therefore, it is likely that planets could form around L1527, just as in our system. This, in turn, will not only allow us to observe what the solar system looked like when it formed, but also to consider these exoplanets as possibly inhabited. Kiel Nebula, and a third-distant Kiel Nebula, was the target of James Webb's research. The Kiel Nebula contains a region of star formation, NC 3324, the edge of which Webb captured in detail. The rock-like part of the nebula is actually hot ionized gas and dust. Amid this nebula, Webb was able to capture with its cameras hundreds of previously hidden newborn stars. Moreover, the telescope also detected thin jets of hydrogen erupting from the top of the nebula. Such columns could probably indicate an active period of star formation. Such an event is very rare, lasting only up to 10,000 years. This discovery is a new step in the study of star formation and its effect on nearby planets and the entire nebula. In addition to the Kiel Nebula, Webb Pillars of Creation Nebula study another nebula that could also bring scientists closer to a better understanding of star formation. The Pillars of Creation Nebula is about 6,500 light-years away in the Eagle constellation. In its huge columns of dust and gas, 4 to 5 light-years long, Webb discerned many young stars that are just forming. Take a look at the nebula's second pillar. The top of it is reddish and looks like lava. This means that there are stars in this area that are emitting jets during formation, which means they are estimated to be 100,000 years old. By the way, scientists also noticed that there should be more stars in this image. The fact is that stars have recently finished their development. They had got rid of the dust surrounding them, so it's difficult to see them in the mid-infrared. But nevertheless, the information from James Webb will be enough to investigate how stars form and emerge from these dust clouds. Brown dwarf, Webb's next discovery, is of even greater interest to scientists. This time, it is not a nebula, but the brown dwarf gas-juiced BD1, at a distance of about 2,000 light-years from Earth. Brown dwarfs are quite rare and dim, and also have some of the characteristics of a planet. That is, they're not massive enough to synthesize hydrogen and emit starlight. But they also have an atmosphere like a planet, with the probable presence of water molecules in it. So, studying why a star has so little mass will help scientists learn more about the boundary between planets and stars and how they form. Now, back to our dwarf. Very little is known about gas-juiced BD1 at the moment. It is about 30 times larger than Jupiter and has a temperature of about 720 degrees Fahrenheit. Brown dwarf researchers, led by Mario Nannino, said that further observations are needed to learn the star's chemical composition and properties. But in addition to gas-juiced BD1, Webb was also able to study the previously discovered brown dwarf VHS 1256 1257b, specifically its dust clouds. VHS 1256 1257b is relatively close, 72 light-years away, so Webb was able to examine its atmosphere in detail. It found many important chemical elements there, including water and carbon dioxide, as well as a cloud of silicate particles. Thus, Webb was able to bring scientists a little closer to understanding the structure of dwarfs and exoplanets. HIP 65426b. The first exoplanet that Webb captured was the gas giant, HIP 65426b. This young exoplanet, 385 light-years away, was discovered back in 2017 by a ground-based telescope. However, the study of the planet was complicated because it was quite difficult to get a detailed image. With short infrared light waves, especially because of the large number of bright stars. For example, the star HIP 65426, around which the exoplanet orbits, is 10,000 times brighter than it. Nevertheless, Webb's cameras took the first direct image of the exoplanet during its mission. HIP 65426b is 100 times farther away from its parent star, so the telescope was able to spot the planet. Although Webb did not get a closer look at HIP 65426b because of the enormous distance. The images will help scientists learn more about the planet and the system as a whole, as well as opening up the possibility of taking pictures of other distant exoplanets. WASP-39b, another of Webb's first scientific mission targets, was the WASP-39b exoplanet. It was previously observed by the Hubble and Spitzer telescopes. But Webb was able to provide an almost complete characterization of its atmosphere. WASP-39b is a gas giant slightly smaller than Jupiter, with very low density, so life is unlikely to be possible there. It is about 700 light-years away from us and orbits a G-class star, WASP-39, similar to our Sun. Though it's slightly smaller and cooler than our star, probably due to its older age. However, WASP-39b is the closest planet to the central star. It orbits at a distance of 4 million miles or 7 million kilometers, which is 8 times closer than Mercury to the Sun. That's why temperatures there are very high, on average, 1,600 Fahrenheit. With its mission, Webb confirmed the presence of water vapor, sodium, and potassium in the atmosphere, which had been detected by previous studies. This year, Webb recorded sulfur dioxide, oxygen, methane, and for the first time on exoplanet, carbon dioxide, which amazed scientists. Sulfur dioxide results from a chemical reaction when it interacts with starlight. And by the way, on Earth, the ozone layer is formed as a result of the same interactions. In addition to the presence of oxygen, according to Kazuma Ono, a scientist at Santa Cruz University, it may indicate that the planet is migrating toward its current orbit. Such reactions have not yet been observed on other exoplanets. So WASP-39b offers scientists an opportunity to study the formation of atmospheres on exoplanets and the history of the formation of the planets themselves. CELS 475b. Finally, in January 2023, it was revealed that Webb had been able to join the ranks of discovered exoplanet with its find. At a distance of about 40 light-years from Earth, Webb, observing a red dwarf, noticed how the light from the star covered the object, orbiting it in just 2 rotations, or 4 days, of the object around the star. Webb accurately determined it was a planet. Thus exoplanet ELS 475b became the first planet discovered by Webb. Making a direct picture of the planet is not something Webb has had success with yet. However, researchers have already been able to give the first characteristics of ELS 475b. At this time, we know that this exoplanet is almost entirely the size of Earth. It has a rocky composition and has a fairly high temperature of about 100 degrees Celsius, more than the Earth. It's not yet been possible to determine whether it has an atmosphere. However, if an atmosphere is detected, a group of scientists led by Jacob Lustig-Jäger believes it could be similar to Venus. Still, more research is needed to establish whether there is an atmosphere there, and perhaps even whether life could exist there. James Webb Telescope has reached its research point in a year. Together with the scientists, they've about 9 more years of work ahead. Webb's main missions are the study of early galaxies, star formation, and the in-depth study of exoplanet and planets in our solar system. Shortly, Webb will probably study the TRAPPIST-1 system, some planets of which may be inhabited. Moreover, Webb will focus on studying the atmospheres of Mars, Pluto, Jupiter, and Kuiper belt objects, which could provide more information about the origin of the solar system. Another mission for Webb is to investigate the sources of water and space objects. To do this, Webb will study Jupiter's icy satellite Ganymede, where there could be an internal ocean. This could also help further studies of icy ocean satellites like Enceladus, Europa, and possibly Mimas. Therefore, we expect that Webb will be able to make many discoveries over the years that will change our understanding of the universe.